It's just interesting to see that problems that we see, you and I, on a day-to-day basis
Mhm.
are not actually program problems. They're industry-related problems.
Hello, this is Jim Carroll. I'm a senior systems engineer here at Avian. Today we're going to be talking about the Cameo, the Dassault Systems Cameo conference that they had recently in Texas, and I'm joined by.
Devontae Casey, pleasure to meet you all. Also a systems engineer at Avian, working with the advanced development team as a product owner.
So Casey, you attended Dassault's conference recently. Can you tell us the purpose of the conference?
So really, the 2023 MBSE Cyber Symposium was really to give industry an opportunity to present some of the more leading topics in the field. So big picture wise, Dassault sent out an invitation for all companies, inviting them to present topics of their choice. Obviously, the best topics made it to the list and were therefore presented at the conference.
So this was Dassault, of course, being a company that has one of the tools for model-based system engineering. So this was primarily for model-based system engineers, companies doing model-based system engineering.
Correct. So a lot of individuals like myself, model-based systems engineers, a lot of companies who are kind of in the forefront of MBSC were also there. And then one thing I'll also throw out is that I would recommend anybody who is a systems engineer, model-based systems engineer, to attend these events. Right. So there's a positive aspect there where you're walking, you're breathing in the same air as the individual who wrote the book, right? And being in their presence and getting to understand things from their perspective as well. So definitely would recommend that for everyone.
So is that so? There were some, I guess, keynote speakers, invited special guests. Really, can you elaborate on some of those?
Yeah. So as systems engineers, especially model-based systems engineers, right? And with me being a newly grad, right? I've just got done reading all of those books. So the standard books you have, SysML Distilled, right? We're also very aware of SysML 2.0 coming out, or it's on the horizon. So just with that being said, being able to see folks like Lenny Delegati and also Sanford Friedenthal,
Sure.
right? It's just a great opportunity to kind of meet those folks who kind of pioneered the industry, if you will.
So the people, obviously, model-based systems engineering is sort of the leading edge of the whole, sort of systems engineering field. Um, did you get a sense that the people there were new to it or experienced with it, trying to learn more, trying to collaborate, trying to find some common ground on some of these areas? I don't know who was there, so can you elaborate a little bit on that?
Yeah, so this is a melting pot, just like our profession is, right? System engineering is a melting pot of all different engineering disciplines. So during one of the lectures or topics, I sat next to an individual who hadn't seen Cameo. He's brand new to it. He is there to receive his first class on MBSE. But on another class or lecture that I attended, I ended up sitting next to an engineer who worked on satellites. It was very familiar with SysML. So the spectrum was literally from zero to hero, all at this one conference.
Wow, that's interesting. You being kind of on the experience side, I would call you more on the experience side of the spectrum and sitting. And it was interesting seeing, I guess, people that kind of were new to the field. So I guess that's a good that's a good forum to bringing new people in, how they can apply model-based system engineering to their field, their domain, so to speak. What were some of the presentations? So this was a presentation kind of, and kind of discussion. What were some of the presentations about?
So our very own, Avian's very own, John DeHart presented on basically conducting an analysis in Cameo and then also other external tools. There were conducting setter events using Cameo and MBSE. Right, we had a lecture from Sanford that talked about SysML v2 and introducing it. You also introduced a roadmap on how to maybe introduce SysML v2 to your program. And then, let's see, one of the other ones. So some of them were more topics to be discussed and further elaborated on. So creating enterprise models. And I actually thought that was pretty cool. So creating an enterprise model at the top level that allows folks like you and I who are on a team to further realize those enterprise models at a system-to-system or system level.
So you and I, and sort of the work that we do, the work that Avian does, is primarily defense related. Were there any other areas that perhaps you see maybe in the medical field, something outside of the defense, something outside of the aerospace field, something along the lines of medical and railroad, anything that might show how the growth of MBSE has gone over the last couple of years?
So the short answer is yes. There were a few topics there that introduced things outside of DoD. Interesting to say, like John DeHart's presentation wasn't specifically on DoD. He introduced like drones and emergency hospitals and kind of UAS operational analysis, if you will. But unfortunately, given that we are in DoD, I kind of stuck to my own there and tried to focus on more of those related topics while I was there. So with that being said as well, Jim, like it was pretty interesting. So at any one time, there were 4 presentations being given. So you had to choose between those sessions on which one you wanted to attend.
Okay. So it was kind of lots of different breakout rooms, kind of different topics being discussed across. Did you get
Exactly.
Did you get a theme? Did you come away with any themes that, the focus areas on certain things?
Yes. So it was interesting because I had a couple of key takeaways from the events and lectures that I attended. One of them is that our industry has a lot of opportunity for folks like us to solve major problems, right? It's just interesting to see that problems that we see, you and I, on a day-to-day basis are not actually program problems. They're industry-related problems. So for me, that was a little bit of a sigh of relief, right? I'm sitting here thinking, man, it's very difficult. This one problem is causing so much difficulty. But in reality, everyone in the industry has the same pain point. So that was kind of my number one takeaway. To further elaborate on that, so I won't call out any specific lecture or anything like that, but a lot of the presentations presented roadmaps rather than tangible SysML MBSE products. And so what does that say, right? That says that we're all kind of focusing and actively working these problems. We have an idea of how to solve them, but we're not quite there yet. So it was good stuff.
So it sounds like the community that you were there with had they kind of knew what the problems were and didn't exactly know what the solutions were. Are still working through the solutions, but we know what we got to do. We just haven't done it yet. And there's really it sounds to me like there wasn't a really in-depth body of knowledge on lessons learned, best practices, anything like that yet. It's probably being developed.
Still in works, right? And I think it's safe to say that those things are out there and they probably were presented at the conference. But the reality is we are so new and the industry is evolving, right? So we need time to solidify these things. I think companies similar to us, well, will gladly provide you a list of best practices, standard operating procedures. But the reality is a lot of that may be tailored towards their specific use case, their project. And so as a whole, industry has yet to, it seems like things are still fluid, if you will.
So we've been, AVN's been doing model-based systems engineering for a while. We have several people that are involved heavily in the modeling. Is there anything that you can bring back personally that maybe you had a problem, you had something you were trying to solve, something you were trying to address, and you had maybe an aha moment that you can take back personally and apply it to what we do?
Yeah. Excuse me too. So I'm gonna grab the book.
Okay.
I'll come back. But so you're very familiar with this, Jim, and one of the things that we see on a day-to-day basis is that we have a system architect who's extremely savvy at what he does. And a lot of people, he's become the go-to guy for solving these problems, right? And the architecture in certain cases may live in his head rather than it being on paper.
Oh.
So one of the classes that I sat through was a end-to-end process on how to create a systems model, right? And so it's going through this book here step by step. It's 300 pages or so, and we're literally starting from zero, starting at stakeholder needs, and then we're ending up with an architecture inside of Cameo. So what I'm recommending here is, we gravitate towards an artifact like this that has standardized steps, and use it as a starting point to enable everyone rather than a bottleneck on one individual. Hey there, John.
Very good.
Guys, I'm really sorry. My computer exploded. I just got through wiping it, so my bad.
You're good.
So why don't you introduce yourself? We've introduced ourselves. John, go ahead.
Yeah, sure. John DeHart, working with AVN, of course, helping NavAir develop their digital environment. I've got, probably 25 plus years experience in aerospace, Lockheed, Boeing, a few other major primes. Background in control systems and modeling the sim. So kind of a good fit for the digital environment, I think. So we're working towards a solution, and it's coming along pretty well.
So we've been talking about the conference, what we took away from it, what we can learn. Kind of maybe your thoughts. What were, I know you were a presenter, so you were sort of the firsthand, sort of the leading person there for any kind of feedback, discussion, questions, and things like that. Your thoughts on that, and then kind of what are some of the takeaways from the conference that you have?
Okay. So quick comment on the conference. They had a, kind of a I'm trying to think what you call that. It's I keep wanting to say trial and error. My head's all messed up from fixing this computer. So, we had a whole track of actual working, Casey, help me out here. I can't think of what the word is. Where we had the whole track where you actually go on there and I help them out and work it out.
Yeah, tutorials? No?
Tutorials. I'm so sorry.
Okay.
I could not think of tutorials. So they had a whole tutorial track. So it was like, 4 tracks. That was the big deal. The tutorial track really, for me, is something that's missing in these conferences because people were coming in and showing just slides. And that allowed us to actually see some real evidence that some of this stuff, not only how it works, but that it's working. And that was a big deal to see at that conference. Sorry, that slipped my mind. I cannot think of that word. On top of that, as part of the presentation I gave was to, number one, to talk about, we're making models, and I see that it's great. Everybody's off working, making models, but a lot of the models are not making much sense to me. And so I'm a pretty experienced modeler, and I'm a pretty experienced simulation guy, and I'm a pretty experienced analytical guy. There's 3 things you got to do. There's modeling, simulation, and analysis. And we're not talking about the simulation. We're not talking about the analysis. Well, I guess maybe we're just talking about it. We're not doing it yet. So we're just modeling. But they go together. You can't just model and then hope. It's like making a key and not knowing that the lock has to look a certain way for the key to go into. So the model's the key, simulation and analysis are the lock. You have to put the model in there, turn it, and then everything starts running. So we're off making models that are they don't seem to solve any problems that I see or serve a real purpose other than to show you pictures or show you some things. Look at them. They really need to be, we need to simulate these models right away. Start putting together the methods to simulate or execute these models immediately. Don't wait. Don't say, hey, we're going to work on that later. You work on it first thing. And it will inform, I was using this term a lot, it informs the sim guys. So my model tells them, hey, I need these things. The young lady asked the question, okay, I kind of described how to perform a very simple mission model with a very simple mission modeling tool. And she asked, well, that doesn't have 3D data in it. How do I inform that 3D data? That's exactly right. You inform that. You don't go get the 3D data. You just say, you put an attribute in one of your blocks that says, I need 3D data. The simulation guy now knows that he needs to bring in 3D data for, line of sight analysis or whatever you're doing, some sort of sensory, look down analysis. But you have to inform the sim guys of that. So, and then when you do that, the sim guy's going to come back and say, you're missing this, you're missing that. What do you want? That goes in the model. So next thing you know, it's like a slinky. It starts going back and forth, back and forth. And then your model changes shape because you weren't right to begin with. You're never right the first time. So as you build your model and as you inform the sim, as you inform the analysis, they will inform you as to how to change to fit. And then the sim guys are doing the same thing. They're getting information from you and they're adjusting their model to make it fit. The analytical guys, which we're not even talking about yet, and I think it's probably the hardest part of all this, the analysis of terabytes of data that you have to really deal with. I think from the system standpoint, we're not even considering that our responsibility. I don't think we think the simulations are our responsibility. I don't think we think the analysis is our responsibility, but they are. So, and one last, to make a short story long, one last comment was, the idea that you inform back and forth is really critical. You got to think of it that way. If you do not think of your model telling a story, it's just going to be another silo. We'll have another simulation silo. So it's not a simulation silo, a systems engineering silo. So it's like, you got to really start thinking outside the box of informing the simulation, informing the analysis, and then those pinging you back with, what do I need to look like to work?
So no, I was just going to say, one of the Avian has a lot of experienced model-based system engineers, and we're heads down in this aerospace defense model-based system engineering work. I asked Casey this question. I'd like to hear your thoughts. Were there any perhaps maybe an aha moment for you, or any kind of personal takeaways that you may have been thinking about a thorny issue, or maybe had some problem that you were trying to solve and somebody came up with an idea? Any personal takeaways?
Well, it kind of rolled full circle in the meeting, or in the symposium. I did mention during the presentation, and this is something I hadn't thought about talking about before the presentation, that version 1X of SysML is a modeling language that is graphical in nature. So that graphics are integrated into the language. It's not like you can break them apart. And when I think about that kind of systems, software tool set, I recognize that the overhead associated with a graphical tool set is enormous. And by the overhead, I mean just managing all the button clicks. And so I kind of stumbled into that discussion because I thought, you drag a block, just like Model Center. I've always had a problem with Model Center. It's a similar problem, a similar concern of mine, in that you go through this whole front end, you got to buy this software tool, you drag a block on. The actual code to do that in a script workflow, 5 lines. But the code to make a block that you can then drag, and then the user can see it and double click it and edit it, is probably 10,000 lines. So you have this overhead of using these tool sets that is enormous. It's enormous, and we don't seem to get that. We want to keep dragging blocks, or we want to use graphical user interfaces rather than get into the code. But the code's very simple. It's not complicated. You just got to get in there and do it. And so my justification for this, this thought pattern or thought process, which I've had since I started working as an engineer, because every tool kept going into a new block dragging tool. And I'm like, why are we using that? Just go write the code. Is because version 2 is exactly that. Took them 20 years, but they finally got there. They finally caught up and said, you know what? We're going to get rid of the front end. If you don't want to have a graphical front end to write in SysML, then just use the code. So they were behind the curve. Now they're catching up to goofballs like myself who I don't use any graphical user interfaces. And the only reason is it's not because I'm smarter than everybody else. It's because I'm more knowledgeable about what goes in there. I know that the code is not complicated. I know I'm just sticking 5 lines here, 7 lines here, 10 lines here. Before I'm done, it's 150 lines that look scary, but I build it in little bitty blocks, little bitty testable blocks. And then you stick them together, it looks very complex. I made the comment about the airplane. You see an airplane flying, it's magical. But when you break it down, it's just some wings and there's some landing gear. It's not a big deal. So when you do the same thing with our SysML models, break them down to very small testable segments. You don't need this overhead of this giant tool set. I was saying that in front of Dassault. I felt bad, they had me in there and I was talking about it. I don't mean that we're not going to have those tool sets. I mean that you should aspire to you should start there and then aspire to moving away from that kind of tool set and work at the lowest level possible, because the overhead of those tool sets it's immense. All the button clicks in Cameo are just as hard to learn as building the systems model itself. It's like, I don't even know what to do in Cameo half the time because there's too many button clicks. So that was something that kind of popped in my head from watching the SysML they had a SysML v2 discussion there. Took a look at some of that, was reading through the charts or the slides, and I realized, that's good justification for my stance that these GUI tools are not really necessary. At least when you're an advanced user and you're trying to build an aircraft, that stuff's in the way, not helping. So that's a comment.
Casey, you had a comment. I think you're gonna ask a question or make a comment on something.
Yeah, extending off of John's DeHart comment there too. Like before transitioning, like think about all the training Friday sessions we've done. That's an overhead that's that's an overhead burden placed on systems, right, to deliver that content to all the other users, which in this case is the entire program for certain models. So just once again, just kind of tipping it off to John there. What I was going to ask is really, I wanted to kind of ask John about the return on investment with Cameo. There were other topics mentioned at the conference that kind of talk towards descriptive models. We know that DoD is trying to put forth models alongside of RFPs and things like that. And I just wanted to kind of open up the floor for John to kind of talk about his thoughts on the return on investment for MBSE in that regard, and stemming away from maybe some of the analysis focused type of work.
Yeah, so that was the first comment I made when I got on the program. First of all, somebody said descriptive model. I was like, what? I don't even think that's a thing. So maybe it is a thing, but it's a diagram. You go get another tool for that if you want to use that. But if you use the descriptive model to generate an automated document, then I can buy that. I can really buy that. I'll say, hey, you know what? That's a good idea. If you automate your documentation from this type of model and that is linked, it doesn't break, don't print it, just use it as a live document, I can buy the idea of a descriptive model being something useful to the team, and it stays live, and it's the front end of your model, if you will. So if you got this whole idea where you're kind of laying it out, can't really execute it, but you still can. You can get in there and work through these ideas. Just because it doesn't run in a simulation tool doesn't mean you can't execute it. So descriptive models don't have to they can describe the actual process and walk through the process. Those processes get complex. They have states, they have activities. They have, all kinds of small details that we don't really look at because we're not simulating them just because we call it a descriptive model. I think that disassociates the idea of running the model because you use the term descriptive. But, I guess I'm just complaining there really. But really the idea is that if you take that descriptive model and then generate some real information that can inform, because when I came on the program, I was like, what are these models? I don't understand these. A model to me has an input, it has an output, it has some constraints, maybe a feedback loop, and that's what a model looks like. So there's a process, by the way. A process has an input, an output, constraints, and a feedback loop. Otherwise, it's not a process. It's a couple steps. I don't know what that even is. It's really just a bunch of steps. I kind of showed that in the discussion during the symposium. I had a list of steps, and I said, look, this is what I'm seeing as models. It was basically like get in the car, drive to the store, buy the bread, pay for the bread, come home, park the car. I mean, that's what I'm seeing a model. I don't know what that even does. What is that going to do? Well, I get the feedback that I'm thinking it's a very abstract model, John. We're going to use that to improve later. Fine. Show me when you're going to do that because I'm not seeing that. I'm seeing that as the model. It doesn't inform anything. There's no way to actually simulate it other than in a linear fashion. So that doesn't really do much for me. I need to see models that can actually simulate the world and do something, provide feedback with that, some feedback loop with that. So it's, that's it. That was fun.
And John, you were out for this portion of the podcast, but we kind of kicked it off. And I basically stated that one of my major takeaways was there is a lot of opportunity in the industry. And that's really what you just kind of proved as well, right? So we're talking about descriptive models, but you're saying maybe the opportunity is really just to produce documentation that you normally would write from the model, right? That's been extended downstream alongside the system's lifecycle. So just another example of where the industry could go, but we need to start thinking in those terms, right? How do we take...
That's a major... Go ahead, sorry.
No, you're fine. How do we take maybe this descriptive model that maybe didn't do anything, but then we add the rigorousness to it and actually produce a tangible thing that is useful and adds value?
Yeah, I mean, it's a major problem I've seen across the board. This is the second time I've tried to work these MBSE models into some real engineering environment. And both times I see major failure because you can't describe the model. Everybody says, oh, everybody's going to get the model, look at the model. That's not fair. I would never expect anybody on this call or anybody I know to hop in one of my ANSYS Dynamics models and understand anything about the model. This is not fair. So I have to go right back then. When I did that, I wrote a huge paper, a thesis that was huge, and they would go read that and get an idea what's in the model. We have to do the same. We're using the model as a crutch right now to not do that because we go, you have this giant model diagram, you're sliding around and stuff, and I can't read them. I don't know what's in there. I don't know what the model even does. I need to see a document. We know the documents are important. I think we do. The rigorous nature of writing a document is difficult to learn and it's difficult to implement. So you have to start it at the very beginning of your modeling session, not at the end. You'll never get a good document. And it has to be improved all the way through the development of the model. And that's hard to do because you already got the overhead of the model. So the model is difficult to do too. But you've got to do your document also. I generally give 15 to 20% of a project to just the document. So 1/5 of a modeling project is the document. That doesn't go away. Hopefully what is there, which is, what's there now would be the link to a live document that really describes the actual case of the model, what the model is actually representing, not a broken link with bad parameters and bad requirements and all that kind of stuff. You want those live. So I think that's the step number one. We're bypassing step number one because it's so easy to drag the blocks into the canvas and call it a model. You really got to step back and go, look, step number one, let's build these things we call descriptive models, and let's see how we can actually show somebody who doesn't know how to model in Cameo what we mean. You're going to have to develop these Feynman type methods where we want to talk to children like babies so they get it, because it's not is not there right now. I can't get it. Look, I'm no genius, but I'm no dummy either. When I look at the model, I don't know what's going on in the model. So I'm like, look, I got to know what's going on, guys. Otherwise, I don't trust you. And so tell me what's going on.
Yeah, like extending off that as well, right? So John is voicing his frustration with reading a model that was developed by another modeler, right? Another fellow systems engineer. But what about leadership, right? Like, what about some of the folks who live outside of the system engineering domain? They're coming across the same challenges, and that, you know, we can't figure it out amongst ourselves. We can't expect other folks to figure that out as well. So
yeah, it's hard, man. You got to have some good skill to do this just in the old way. Now we're trying something new on top of the old way. It's even more difficult.
Yeah. So I like Casey, you mentioned that there was a session on systems engineering technical reviews, which really is, you know, sort of an independent assessment on technical maturity of whatever the program may be, whatever it is, whether it's you're building some infrastructure or something, or you're building an airplane. That involves people that will probably not have much, if any, modeling experience. It is at least in my mind, it is good to see that somebody's thinking that this modeling world we live in, culture, we have to interact with the non-modeling world and the non-modeling culture, because now that may be a transition period. It may be 20 years, because our senior leaders and wherever they are probably are not very model savvy. I think I could be wrong. So there's got to be this interaction between people that understand models, and people that don't, so we can get into a digital environment, a truly digital environment, without having to make a bunch of PowerPoint slides and sit down in front of senior leadership and say why you believe a program is technically mature, rather than just opening up the model and just walking through the model. So I did have another question kind of for both of you from the conference. Were there any conversations you may have had with any of the participants that perhaps kind of indicates that some people, and this is probably a loaded question, going in the wrong direction, perhaps, maybe? I mean, something that maybe on the standpoint of why are we kind of looking at that? Why are you spending your time on that? Anything like that? Anything along those lines?
No, I mean, everybody's pretty gung-ho from what I can tell. I do. So I will say that part of what I was presenting, and I'll admit the presentation had a little bit of, it was a little fluff up front, 4 or 5 slides of me really just complaining, you know, about things like, you know, one of them was, look, I see people making models, but you don't have an objective for the model. What's the model supposed to do? Well, how are you, what are the goals for the model? Why are you modeling at all? And I got I could see people in the crowd going, yep, I mean, you know, I'm there.
Mm-hmm.
I hear you, Matt, because it's not, we're making models, and this, you know, a descriptive model is a pet peeve of mine right now. I'm like, hey, you're making a descriptive model. It better describe. That's the whole, I mean, that's in the title. So tell me what it's describing. Nothing. It doesn't describe anything. I can't even read it. So I kind of went on a little bit of a tangent early on. I think I just had 1 slide on it, but I did discuss it. You know, that, hey, look, you better, to me, before I model, look, I know how complex a model can get. I'm really, I'm territorial almost when I get into a model. I don't let people touch it, because you can blow it up in 10 seconds. And I've got a year-end thing. So it's important to have a plan up front. Say, hey, I've got a plan. Here's what we're going to do. Here's what I think's going to happen too. So I have a test in there that says, I think this is going to happen. I test it. It doesn't happen. Now what? But at least I know. At least I had a plan. At least I was doing something. And the model will probably be close if you do it that way. If you're just modeling for sake of modeling, you're going to end up with, you know, it's like there's no rudder. So no feedback loop.
I didn't come across anybody who maybe, you know, headed in the wrong direction. Generally, everyone I spoke to is just like what John said. They were pretty gung-ho about Cameo, SysML in the future. But I will tell you, I think John's presentation was a little eye-opening for me. Now, keep in mind, this is the first conference that I've been to that's system engineering related, and I just graduated, right? So attending that his presentation was kind of gave everyone a little bit of a wake-up call saying, hey, what are you doing? It was interesting to see those heads slowly nod and say, I think he's right on this one, right? Where's the value added? Or I think we were promised something bigger than what we currently have. So how do we get there? And so John kind of showed him a methodology to actually get to that end result, to inform you on decision making, right? So that's that. Definitely recommend everyone check out the presentation. And then John also has some of his the code and things like that hosted online as well.
Yeah, I know a lot of instances, kind of going back to what both of you guys were kind of alluding to. A lot of tend to be smaller programs that are say, well, we want a model. We want a model because that's the next big thing, and they really don't have a purpose, and they don't have perhaps the right people involved in their modeling adventures. So we're seeing that a lot. There's been some cases of that, and they can get frustrating. They can get the programs can get frustrated when they spend a lot of time, spend a lot of effort, spend a lot of money trying to model something, and they really know there's no use for it. They don't have any usefulness of it. So,
well, I don't think they're giving it a chance, because they're, when I start modeling, I don't just assume my first model is the right model. In fact, I know my first 10 models are going to be junk, because I don't know what I'm doing. Even though I know what I'm doing, it's a new model. It's a new thing. I'm trying to figure it out. I'll have version A, B, C, D, E, F, G, H, I, J. I'll delete those and start again, A, B, C, D. And then I'll delete those, and it'll be A, B. And then when I've got to remake the model after I go through that horrible process of trying, is easy. Now I've done the hard leg work up front. And, making the first A to B took me 5 days. The last A to B takes 2 hours. It really is. It compresses so much once you learn what makes sense, and once you go through the process of rolling the model over and over and over again. Delete your model. Delete it. Don't keep that first model. Delete that damn thing, because you're not going to want to look at it. You were wrong in the first place. So it's an important process to learn. It's I just think that a lot of folks are green. They don't know that your first model is your worst model. So start rolling that process around over and over again to improve not only the model, but your, what you understand as the model and how it should look.
Painting the picture as well for everyone else who may not be very aware of MBSE and system engineering. A lot of the programs have had Cameo come from the top down. So I was on a meeting yesterday with some folks from NASA and then also DoD, and they literally said the same thing, right? They were told, here's the tool, go solve all the latest and greatest problems. So that's also how you end up in a situation where you don't know what the endpoint is, but you have this tool and you're actually modeling, trying to create, right? You're really in the process that John's describing, where you're A, B, C. You may still be at A, but you're working your way through this process to ultimately find out what the end game is.
Yep.
Hey, Jim, can I ask you a question?
Sure.
So, to me, a big part of this is, and the first step, really, besides descriptive models, which I'll never get over that name, is requirements management.
Yep.
But I don't see a lot of that going on. So what's the deal with us not having a full on, a focused effort on managing requirements yet? Why is that not a thing? I'm just talking about us, the Navy and NavAir right now, at least our teams.
So I'll give you my opinion. We're focusing, the program's focusing a lot right now on setting the stage for model-based systems engineering. And we're trying to do this model-based system engineering in the larger defense acquisition system process. So there, and in all honesty, that is a ton of work. Everybody says, what is model-based system engineering? And they say, well, it's just system engineering in a model-based environment. Okay, that's a nice tagline, but there really is a tremendous amount of ways, methods that we have typically done that are going to be different in a model-based environment. So we got to set that foundation up first. One of those things is going to be how we create requirements, how we link requirements, and then how we're going to manage those requirements. So when you talk about requirements management, that's kind of something where you have, if you will, a set of requirements already. And what I mean set of requirements, you're talking about big requirements down to small requirements. So in a model-based environment, you're going to go from something that says, hey, I need an aircraft to have a capability to attack surface targets. So that's a big capability. And you take that and you can neck requirements, all the different requirements, all the way down to what a bracket on a piece of avionics equipment and how it fastens to the bulkhead of an aircraft. You can have traceability all up and down. So there's just a lot of work that needs to be done to set that foundation first. Not saying that it's not important, but I just don't think it's something that needs to be addressed today. That's kind of my opinion.
Doesn't the foundation need a set of requirements? I mean, to me, I feel like we're missing an opportunity to learn how to manage requirements in a model-based environment by not setting requirements for our foundational elements. It's like we're making things to use, but we don't have a set of requirements for them. It's just based on conjecture at this point. There's no tests associated with them. There's no rollback, normal process required. Because these are essentially pieces of software we're writing.
Right.
It's really what it is. And so when you write a piece of software, you have a set of requirements. You have a SDD, SRS, all these fun things. I'm not seeing those. And I thought, I don't know, it's not, when I say that, I'm not getting any feedback that I was expecting. I'm thinking that we should be testing requirements now, regardless of whether it's on an aircraft acquisition or the foundational aspects of your digital environment and your MBSE methods.
So, Jim, just give you something to think on that one. That's actually what our conversation, our meeting is about, John, after this, is I'm trying to propose to look at the product that we're developing, which is a model-based CDD. It shouldn't actually be called model-based CDD, it's a CDM. But regardless, let's develop requirements for that, right? It's ultimately the JSIS manual is your requirements, right? Because, one of the requirements is you have to have a waiver if you want to deviate from that standard template that's usually used for CDDs. So let's start there. But interested to hear your perspective as well, Jim. That's the way I'm going. Otherwise, you can get kind of lost in the sauce and you don't have that traceability from the very beginning.
Right. So one of the very interesting things that we've been learning on the program, and at least what I had understood the defense acquisition process to be, is how we set requirements for a material solution. The warfighter needs a material solution to do something, and there is a big process within the Department of Defense to do that. What I've found, and I think what we're finding, is they haven't really, that process doesn't have, they tend to be a little bit more standalone processes within the sort of sub-processes that don't have a lot of linkages between each one of them. And model-based system engineering demands to have this traceability, and I think we're struggling may not be the right word, but we're finding some challenges in setting up that traceability when kind of by design that traceability doesn't really exist. When we go from something like the ICD to the analysis of alternatives to the CDD and your mission analysis work that's done within the capabilities-based assessment. All of those three things you would kind of think has this big traceability down to I want I want an attack aircraft to do this, that, and the other. And now you're getting to the point where, well, there's not that traceability that says, so how do you kind of create that traceability? How do you make sure you have methods to address those stovepipe processes kind of thing? So, when we say we have requirements, yes, there's a requirement set for creating a capabilities, a CDD, capabilities development description document. The problem with the CDD is you would think it has a direct link to the analysis of alternatives, and when in fact it doesn't seem that that's really the case. So now it's kind of, where do you start modeling? Where do the traceability goes back? You lose the power of modeling if you don't have this linkages, because if you did, you can theoretically understand everything about how your weapon system is going to be behaving, and all the way back up to how it fits into sort of the warfighting analysis, the campaign analysis, and sort of the big wargaming kind of thing. So I think that's some of the stuff we're trying to learn.
Yeah. Yeah, that scene, Casey and I talked about this. He mentioned, the idea is not to take the documents and just copy them in the model.
Right.
We have to come up with a new method. And so part of fixing what you just talked about is probably the new methods we've got to come up with.
Right.
Rather than just copy paste, and then it becomes another descriptive model.
Sure, and a document is just just information, right? So you can have text information within the model, and it's just preamble stuff. But there's information in some of these documents that's, no kidding, has some meaning and traceability to some other things. So that's the exact purpose or the exact usefulness of what a model can do, because that information resides in a model that can be linked to something else that then is linked to something else. So when you create a CDD, if you will, all you're doing is you're taking the instance of that information and putting it down on a piece of paper, and it is only as good as when you've printed that document out.
Yeah.
So I hear you. I have so many thoughts there, Jim, right? Like, I just think back when you say that, I think there needs to be like a context diagram that shows what are you interfacing with, right? What's the purpose? How are you going to mature? What was written down in the ICD, CDD? I just think there's room for things to be new, right? And I think part of the problem is when you start to deviate from what is known, it's hard for everyone else to keep up with you, right? And we did some of this with the PSA.
Yeah.
The moment things start to look very different, it's hard to keep the unit together on the development of that project.
Is it?
But that's just me rambling on.
One of the unique things that we have in DoD, not just NavAir, but anything in DoD, is this what we call the acquirer-supplier relationship. So when you're a Boeing and you're creating the 787, let's say, or the follow-on to what the 787 Dreamliner is, Boeing owns everything. They own the entire thing. They create customer requirements that they perceive as customer requirements. Nobody gives them that says, hey, you need to build an airplane that looks like this. They create those customer requirements within their sort of marketing department. What we have to do in DoD is we have to create a set of customer requirements, and then we have to go find some company to go build that. So there's a transition between what we require and what then the supplier, if you will, the suppliers will be building. So there's that transition, acquire-supplier relationship that a lot of other companies, other commercial type entities, they don't really have. So something to keep in mind. And that adds an extra layer on some of the complexity that we have within DoD.
Yeah, it's definitely different for me because I'm coming from the actual industry side of things.
Right.
Difficult for me to get some of what's going on here. So I'm still learning that.
Yeah, it's you have issues like intellectual property. We have issues, so that's an issue we have to recognize with companies. The other issue is we have to ensure we aren't too restrictive in what we tell what we tell the suppliers what we want. We want to give them some trade space and some room for creativity, and certainly being able to meet the customer requirements. But it's tough to sometimes go, we're being too restrictive here. We don't need to have those kinds of, and that's just not a model-based thing. That's that acquire supplier kind of relationship, which is going to be more pronounced in the model-based system engineering world. All right. Well, thanks. We had a great conversation about the Cyber Symposium that was hosted by Dassault. I think we're all still learning a lot of information. I think we have a lot that we can collaborate with in some other organizations and some other activities. Yep. Thanks.
Yeah, thanks, guys.